Well, hi, and thanks for joining me in my shop today. It's Wednesday, November 9th. It's 1 degree outside, and both my cats are inside because of that. So, things are getting a little bit interesting with this radio as I've been poking along, kind of shooting in the dark a little bit with my SDR to see what kind of things I can discover, encounter, do with this radio. So, we're going to jump on the schematic in a minute. So this is the connection to my SDR antenna. My SDR is this little box over here. I have a number of SDR radios now in the house. I use these a lot. Here in my shop I use this one for experimenting and stuff. But I have others. I have 3 other SDRs. One that's a little similar to this, a different brand but a similar style of radio. I have an SDR based ham transceiver that I purchased just a few months ago. A fantastic little radio and not an awful lot of money for it. Fantastic. And then I have an SDR Play, which is a higher quality SDR radio of this sort. Not really of this sort, different chips inside of it. So it's much more of a radio. Then this guy is a bit of a let's just say it's been altered so we can reach out and do shortwave stuff and things like that, this style of radio. Anyway, fantastic radios in many respects. So, what are we going to do today? So we're going to move a little further in the radio. We're going to leave the detector area. We're going to get into the audio part of the radio. And what am I going to do with a RF radio in the audio part? I'm going to find out if there's any radio signals in the audio part of the radio. That's the first thing I want to do. So let's have a look at the schematic here. Now the reason I think there might be some RF left in the audio circuits of the radio, and of course we wouldn't hear that coming out of the speaker, at least I can't imagine how you would hear it, is because I found there was a lot of RF left right at this point. At this point here. This is where I was testing yesterday, right here. I'm going to leave I soldered a capacitor onto this point, and I discovered also that this is a pretty rugged area in this radio. You can do stuff to this location and not much happens. All I ever noticed was a little bit of loss of treble in the audio signal coming out of the speaker. So I leave the capacitor there because I have some future ideas, probably for tomorrow, and that capacitor will be helpful for that. So we're moving on. We're going to come and check what's coming out of this tube. If I try to check on the grid here, I'm sure I'll have trouble with disturbing the radio operation a lot. So we won't touch this grid. But out here on the plate, the situation is different. Now let's see. I could go. So this capacitor C16, which I replaced. I'm pretty sure I replaced this one. Its job is to get rid of RF in this circuit. So no RF continues onto the grid here. And I'm interested in whether there is RF making it to this grid. So I have a number of places I can connect. I can get right on here. I would use a capacitor myself, so there'd be a capacitor coming off and then a wire going over to my SDR antenna. I can connect here, or I can go on this side. If I go on this side of this capacitor, then I'm starting to see what's really on the grid here. Except I'll be disturbing this part of the circuit now. Would it be significant? Probably not. This potential of this DC-wise is around 0 relative to the chassis. The biasing is generated by this cathode resistor here. So I wouldn't disturb the bias on this tube. And if I use a capacitor again, tap off, this is probably the better place to go to start with. Go here and not go here. R16, how big is R16? Probably, I'm going to guess 20,000 ohms? Ooh, off by a factor of 10, 270,000 ohms. That's a very large resistor there. 0.01. Yeah, I'm going to go here. We'll see what happens. So what I'll be doing is I'll be using the SDR to see if there's any RF left. And what RF am I talking about? Really the output of the IF string here, which provides a very strong and powerful signal at this point, which I now realize, just from doing this experimenting, is a big problem for the radio designer to contain it and keep it from getting back to the front here, where you have, especially here, you have a very sensitive circuitry, maybe even here. Very, very sensitive circuitry here and here, and hooked up to an antenna, for crying out loud. This can pick up what's coming out of here, run it through again. So how this is handled is of interest to me. Normally there's a few capacitors that are used to, quote, decouple the radio. So you're trying to reduce this coupling of the outputs here with the inputs here. And of course this is one of those decoupling capacitors here. And these guys, even the supply capacitors, act as decoupling capacitors, but they're not particularly good because they're electrolytic. So you need something a little more. Sometimes there'll be a parallel, like 0.01 or something reading here, but not in this radio. It's a cheap radio. Don't need that part. Don't need that part. Okay, and we were looking at the wrong schematic there for a bit, but they're almost identical. Very good. Let's hook up here and see what we get. Now, if you don't realize this about me, I'm doing this stuff just live, and I'm taking guesses at things. I'm trying stuff that I think won't even work when I'm trying it, to see what happens, because I get surprised from time to time. So bear in mind that's the situation here. So we want to hook this guy up. We want to use a capacitor, and we want to get on the grid of the output tube. The output tube is this one here. 50L6, I think is what it is. Was it not? 50L6? Let me just peek at the schematic to be absolutely sure. 50L6. It is 50L6. 50L6. So it is the plate. No, I'm sorry. It's the grid coming in. What am I saying? 50L6 beam power tube. Signal grid is number 5. Pin number 5. Okay, pin number 5. A little more light in the shot. Pin number 5. Okay, here's the key. 1, 2, 3, 4, 5. A little tight in there. There we are. So I'm going to hook up the SDR, but I'm only going to hook up the antenna to start with. Don't really know what to expect here. Am I going to connect it right from the start? Be a little worried that there'd be a small charge built up on the... If I didn't have this connected. Don't worry about it. It's a grid. There's no voltage. Okay, nothing to worry about. I keep thinking I'm hooking up to a plate. Okay, we might as well turn on the voltmeter over here, simply because I have it connected on the ADC line. Keep an eye on that, just for fun and excitement. It's really about the SDR. So I've got my signal generator running. It's out of the picture more or less at the moment. It is connected, but I don't really care about it. Let's start up the radio. Good show. Everything's normal. So I'm going to let this warm up a little bit while I drink a bit of coffee, and then we're going to take a look at the SDR results and see what we get. We're getting my signal generator. There we are, but it's working. Good. Coffee. Well, let's think about this. If the IF frequency itself is making it all the way through into the speaker circuit where I'm examining it, then we will see something when I hook up down in this area. So we can do that. Let me raise this a little further. we'll mark 460. May not be 460, maybe double 460 comes through. 460 is right here. Okay, so I'm not even connected to the radio right now. So I'm going to make the connection, hook the antenna up. The radio's not even turned on, Jim. I turned it off. Okay, radio coming on. I have not connected to it. I'm going to stop. I'm going to put this screen. I'm going to change something here. I'm moving a little too quick on my computer and thought I was recording when I wasn't. So unfortunately, I'm going to have to just repeat what I just did. And what was that? I hate going back and repeating things like this, but it's worth checking this out. So what I'm saying here is, right now we're looking at this area of the radio. Any connection I make is killing the signal to a large degree, probably affecting the general operation of the radio at this point. This is a high impedance location here. It's a 500,000 ohm resistor here. There's a 250,000 ohm resistor here. This is high impedance, so hooking up to it is really affecting this a lot. The input to my SDR is only a couple hundred ohms. And even though I've got it in series now with 10,000 ohms, it's still enough to kill this. The capacitors which are supposed to be dealing with this problem, as I understand it, would be this guy, and ultimately this one too. And what's the problem? The problem is RF continuing on through the radio. And I didn't suggest now that the earliest radios, this problem was not well handled. When back in 1920 they whipped out their SDR to examine things and look on the computer, what did they see? Nothing. They had nothing to kind of see this kind of stuff. Just the crudest of technology. It's really quite impressive when you think about it, that people were clever enough to figure out how to make radios before there was a radio, when everything was a question mark. Absolutely everything. The instruments, if they can even call it that they were using at the time. Yeah, human beings, very impressive animals on this planet. Dogs are okay too, but humans are way more interesting. Okay, so that's why these capacitors are in here. Each step of the way, every opportunity to null out, get rid of, kill, reduce, make lame RF in the audio circuits is taken. That one, this one. At the same time, they have side effects, tone effects that need to be considered, or just volume and the amount of audio left to come out the speakers being affected by these capacitors. So careful selection of capacitors and related resistors like this one here in order to achieve the right kind of filtering, to leave the audio, kill the RF, or even alter the audio slightly to make it more pleasant, more pleasing. What I want to do is move, because we're finding a lot of RF here, it makes me wonder, is this capacitor doing the right thing or not? We already fooled with this one. Didn't seem to make much difference. Something frying in the radio right now. So, not sure what's going on there. Radio just decided to make some noise. Let's move the antenna, the SDR antenna, over to here. We'll see what's actually heading for the speaker, which still has this big iron core transformer. Can't imagine RF making its way through here to any great degree. So the RF has an alternative route, and that's down this way. So this is a bit of a filter right here. So probably very little RF can be measured at this point. But another amplifier boosting it up. Let's go see. Okay, if we want to move from the grid, turn this down. I'm going to remove this. Yeah, I'm going to turn this set off because things are pretty close in here. Really close. Okay, and we want to find the plate of that tube. 50L6. 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 plate is on number 3. The plate is on number 3. Okay. Go here. Take this off now. Number 3. Looking at this tube, and we're counting. We're counting 1, 2, 3. 3. So this is. Look at this capacitor. I didn't put this in. Someone else put this in. What size is that capacitor? What size is that capacitor? Radio's off right now, so let me take a look. I'll show you the back of my head for a moment. 0.02. It's a 0.02, and it's supposed to be 330. Isn't that right? We'll have to look into this a little closer. We'll have to look at that. I thought there's another one of this type of capacitor down here. It's a nice job. Whoever did it did a nice job on the work. But I wonder if that's correct. We don't know right now. Okay, but it's on the plate. That's where I want to go with this. Double checking. 1, 2, 3 for sure. Okay, that can't really go anywhere. Good show. We're going to put the resistor on here. Now, I can't imagine there's any significant antenna effect. I mean, this thing can't pick up enough oomph to go in the radio at this point and cause anything. That's my belief. But there's going to be a 120 volts on this side of it, because I'm on a plate. I'm on a plate. Okay, well, you're looking at the. I don't have to do that. Okay, so I'm going to hook up to start with, because I don't want there to be a charge build up here, and then I clip on my SDR. That's the end of that. I don't want that to happen. I'd rather burn it out more directly this way. Okay, we're watching it on the SDR. Turn this up. Give it the full duty for some reason. Anything funny happen up there? I don't think so. There's that weird sound. So I don't see all those artifacts. There's nothing at 460. If we look at the red line, let me set it right on 460 here. The red line here, ignoring this scratchy sound. Okay, so there is a little, so you can see the local oscillator and you can see the IF signal. Somebody said to me, why don't you try watching what's going on in the IF by hooking up to the speaker circuit? I think I would say, what are you talking about? But there it is. And the local oscillator is just showing up too. Now, interesting question. How much of this is coming because the output tube is amplifying it? How much of this is just my setup picking stuff up? You know what? I could pull that output tube out, and we could operate the radio and see if these things are still there. Now let's think about that. They should not be there if the tube is amplifying them, and that's why they're there. I think I need to do that. Okay, so we're going to shut it off, let it cool off for a minute, and drink some coffee. Well, actually, quite a few hours have gone by. It's late in the afternoon now. I got tied up doing other things, nothing to do with my shop here. So I've just come back in. I thought, what was I doing? Right, I was going to pull out the output tube and then see what happens to the radio. Well, what'll happen to the radio is it's not going to work. because all the tubes are in series. You can't pull one out and have the rest operate. Duh. So what am I going to do next? I'm going to try something entirely different. I guess you could say. And now for something completely different. I'm going to approach this from a different point of view. I'm going to say, gee, look at this radio on my bench. I've never seen it before. Wonder if it's leaking any signals all the way into the audio side. That would be the question. How could I find that out? What about a signal tracer? So I'm going to try using my signal tracer here and just see if I can somehow find out yes or no, or realize using that instrument yes or no these two signals, the IF signal and the local oscillator, are making it all the way, say, to the grid of the output tube. That's the plan. Okay, let's switch it on. You might say, well, is that even a sensible question to ask? Are these signals reaching the audio circuits? Could be. I think after doing this to a number of radios, it'll come clear as to whether all this kind of monkey business is valuable in trying to fix up radios, make them work better and correct and all that. Okay, so this is the ground. I'm going to put this onto the A minus here. Volume is down. Radio's not even switched on. Again, this radio is plugged into an isolation transformer. At least one. Okay, here we go. Good show. I think I'm just going to leave it on. Leave the dim bulbs in because it's getting 108 volts. That's got to be enough. Do the trick. Now you see I've left this clip lead here. That's just for safe and easy contact with the grid of the output tube. Pin number 5. Okay, so what are we going to look for? We're going to look for the 460 because that's one frequency. A local oscillator, it varies. So, but we know the one should be 460. So this is basically a radio receiver, but this is not a super heterodyne radio receiver. Every stage is just an RF amplifier, then detector, then some audio. There is no frequency conversion in here. So right now it's set to RF for radio stuff, because you can also do audio stuff. It's set to band A. Band A, here amongst all these decorations. Band A is basically a range of IF frequencies. 460 is up here. There's a little bit of 460 in me. Can you see the magic eye? You can kind of see there is a magic eye here. Okay, so I'm going to touch this now. Just stand back a little bit. I'm going to touch this to the clip here, and we'll see if there is a signal there. Wait a minute. I'm not tuned into anything. Well, I think it would hear the same hiss, but we might have a hard time believing what we're hearing. So let's. Of course, I could tune the radio. Changing the local oscillator won't affect what I'm doing. I'm listening to the. Okay, good. Let's turn this down. Let's turn this down. Try and just see if I can kind of twist this in here. Lovely. Okay. Okay, that's great. No, it's not great. This means that we're able, no, it is great. It's great and it's not great. Probably not so good for the radio. Might just be indicating it's a cheap radio. That's really what it might be indicating. But it's great because it's kind of showing how easy it is to kind of become aware of this effect in a radio. How easy it could be. Now, a local oscillator for sure is going to be there. It's also kind of verifying, I guess, that what I've been doing with the SDR is valid. That these things I'm seeing and finding are real. Good. Okay, so we'll try the local oscillator. So to do that, well, the radio's rate, wow, just happens to be just about 1,000,000 there. It's on 1,000,000. That means the local oscillator is 1460. So we'll come over here. We're going to change it to band B. Band B is here. And we're going to tune in. It's a regular broadcast band here. 1460. Well, we'll be right up at the top of the dial here. Now it's not modulated. So we're going to put this at 1400 or so. Then we're going to tune the radio. And that way, I think we become aware of its effect here. Huh. Something a little weird happened there. Something faded in and out unexpectedly, but not now. Okay, so what I'm going to do, should only hear it once or maybe twice. So we're down here at the bottom. That would be that's 5,500 here, or let's say 500 for easy calculating. I'm kind of losing my mind because it's late in the day. What I was going to say was the local oscillator. Well, the local oscillator is going to be 450 above that, about 9. They double the local oscillator. It's 18. It's off the scale. So that's not by accident, I'm sure. The fact that you can tune the radio as low as possible, bring the local oscillator as close as you dare to the band you're actually listening to. So the second harmonic doesn't come into the band. Doesn't make any sense, I don't know. Good. And the only place we heard it was in one place. One. Multiple heterodynes as we go through. Listen to this radio. I'll go back. Okay, and listen to both. Okay, so I'm benefiting from hearing this in stereo with my ears. In some cases, what was coming out of here was kind of matching what was coming out of the tracer. In other cases, not so much. Of course, it's a complicated mishmash of stuff going on again. Good though. Happy with that. Good. So, I'm off to do other stuff again. Thanks a lot for watching, and I've got a couple more ideas yet what to try with this radio. Thanks a lot for watching.